Okay, in the last session, we started discussing, introducing what is data mining, the definition of data mining, why do we need to mine the data, and finally, we also briefly introduced the data mining tasks. Okay, what kind of data mining tasks have we introduced so far? We have introduced the classification task, the clustering task, and the association rule discovery task. Okay. Now, what's left are actually three more data mining tasks. The first one is the sequential pattern discovery. Again, it's very similar to the association rule task in terms of that we are searching for dependencies between different objects or items. Okay. In the association rule, we were trying to find, for instance, which items are usually bought together by a customer. In sequential pattern, the key word here is sequential. So this means the items are not occurring together, but actually following each other. There are sequential dependencies. So, for instance, if I have item A, then this and I have a certain frequency for item A. Then or event A, then this will be followed by another frequency of item B, and then by another frequency by item C, for instance. Okay, and having this pattern of A, B, and then C, this could lead to the occurrence of an object or even a set of objects like D and E. So in this case here we have A and B that occur together, followed by C, okay, that has also a certain frequency. So in this pattern, A, B, then C, it will lead to the occurrence of D and E. Okay. Most important in sequential pattern, since we are talking about sequences, so we have to be concerned also about time. Each event of A or B or C, whatever, has its own timeline. So it occurs, the frequency of each item occurs based on a certain timeline. Okay. So as stated here, for instance, let's say that these are variables for time. So A and B will occur at a time scale less than X whatever. C would occur at a timeline that is greater than NG, etc. Okay. Example. We usually use sequential pattern discovery in following applications. For instance, in telecommunication alarm logs. In telecommunications, they usually have big databases that store that have big logs storing the different alarms. So, for instance, if this is a rule that has been discovered based on sequential pattern discovery task. What is this rule? It says the following. If we have a problem, a certain problem in any, for instance, in an inverter or any other device, okay, and we have excessive usage of current or excessive line current, okay, then this would lead to a certain alarm, okay. So if we have a problem combined with excessive usage of current, then followed by a certain alarm, then this might lead to the occurrence of a fire alarm. Okay. Another example is in point of sale transaction sequences. They have found the following rule: when customers buy, for instance, in a computer bookstore, when customers buy a book about Visual C, introducing Visual C, then buy a computer, a textbook about C++, then this would usually, this pattern of buying Visual C, then C++, would usually lead to buying a third book, which is called Perl for Dummies. Okay, Another example for point of sale is in an athletic apparel store. They have found the following rule. If you buy shoes followed by buying racket and racquetball, okay, then usually this would will lead to the occurrence of buying sports jackets. Okay? Is this clear? Is the sequential pattern discovery clear? Okay. Then we continue with the following data mining task, which is regression. I think all of you have taken statistics, if I'm not wrong. And you might have heard, of course, about regression analysis. In regression, again, regression searches for, again, also dependencies, where a variable, where the value of a certain variable like y is dependent on the values of other variables. So it's like a function. For instance, if I write the function y is equal to x plus x squared, for instance, plus 2c plus 2c plus 5b. So this is, for instance, a function. Okay? Now, this function means that the value of y depends on the value of x and x squared and b and c. So, back to the definition now. Regression predicts a value of a given continuous valued variable based on the values of other variables. Okay? Now, this dependency could be either linear or nonlinear. So the dependency of y on the other variables could be linear or nonlinear. This will be discussed, of course, in details, inshallah, when time comes. Regression is a technique used for data mining, and it is originally comes from statistics and also used in neural networks. Example: predicting the sales amounts of new products based on advertising expenditure. So you can have a regression analysis and make a function of product sales, how much sales you will gain from spending money on advertising. So where is now the dependent variable? What is our dependent variable here in this example? If you can write down or just use the mic. If I may say, where is the y here? Which variable? Any reply from anyone? Okay, the dependent variable will be here. What will be the sales? Because now I'm predicting the sales. So the sales is dependent on advertising expenditure. Okay, so we're trying now to, if we have certain amount of advertising expenditure, we'll try to predict the amount of sales we can make. Another example would be predicting the wind velocities as a function of other variables like temperature, humidity, air pressure, etc. A third example would be predicting the movement of a stock price, which we call it time series. Okay, why do we call it time series? Because a stock has always a price, a value for a data point. And data point, and this data point represents a price value at a certain time. So having several data points at different time points, this is what we call time series. So we can predict the pattern or the time series of one stock based on, for instance, various economic factors in the market, etc. So this is again another regression analysis. Okay, is regression clear? Is it clear regression? Okay. Now the question is, can you see the difference between regression and and the other, because we have here, someone might say subregression is also based on dependencies, sequential pattern is based on dependencies, and association rule is based on dependency. Regarding association rule and sequential pattern, they are both descriptive, while regression is actually more predictive. It predicts the future, whereas association and sequential pattern, they just describe the current status and try to find dependencies among the different items that we have. Now, what is the difference again between association and sequential? Sequential is concerned more with time. So it's not, so the events or the items do not occur together. Now, no, actually we're finding here, or we're searching here for sequential dependencies. What comes after what? All right? Last data mining task is deviation and anomaly detection. This is the sixth data mining task, where we try to detect significant deviations from normal behavior. Again, we'll be using here some mathematical functions. Okay, what is the application? For instance, credit card fraud detection. Another one would be network intrusion detection. So you can find out if a hacker is actually trying to intrude a network. So this is another application. Again, the deviation and anomaly here, this would be descriptive or predictive. Descriptive or predictive? Now, would you wait until the network is hacked or intruded, or you have? So this in that case it will be descriptive. You're just describing that the network has been hacked. But if you're trying now to detect, but in the case of, let's go back to remind you here, deviation detection is predictive. But in case of trying, what you need to do is to be able to predict if this network is being hacked or actually will be hacked by an intruder. So in order to prevent it, okay? So it is predictive, not descriptive. And how would you be able to predict that? By using, for instance, certain the history, certain functions, and certain symptoms that are starting to occur. So you prevent it from the beginning. This is just a very logical explanation, but not, of course, the scientific explanation. Okay? Yep. Now we finish now all the data mining tasks. What we have now the challenges of data mining. Challenges of data mining. Having now been introduced to what is data mining and knowing that data mining has to deal with enormous amounts of data, so we have some challenges. First one is scalability. Okay, we have enormous amounts of data. The data can be too big, so it needs to be pre-processed, and as you remember from the graph that we have shown last session, so it needs to be pre-processed before being able to be data mined. So the scalability is a very important issue in data mining, because data gets larger and larger and larger. Dimensionality, I have already explained what we mean by having different or many dimensions for the data. I told you, like, it can be represented like a cube, or even something that has more dimensions than a cube. 5 dimensions, 6 dimensions, 7 dimensions, whatever. So again, dealing with data of this high dimensionality is very difficult, so we need to account for that. Complex and heterogeneous data, already we have mentioned why the data can be heterogeneous, because the data sources can have different formats. For instance, one can be an object-oriented model, another can be a relational database model, a third can be just text documents, a fourth can be XML, so we have heterogeneous data, and they come from heterogeneous locations. Data quality, we need to be sure, of course, of the data quality, or else we'll be making wrong decisions based on the data mining evaluations. Data ownership and distribution, this is a very critical problem, especially when it comes to the type of data that you want to data mine. For instance, if you want to data mine or you want to mine the stock data of different companies in the market. Now, this stock data belongs to whom? Don't say that it doesn't belong to anyone. Actually, it belongs to the companies and it belongs to the brokerage firms. So you need to first, before mining the data, you need first to know who's owning this data to give them their proprietary rights. Okay. Privacy preservation, again, despite the fact that data mining helps us to discover hidden knowledge, however, in order to discover this hidden knowledge, we need to have detailed information. And sometimes these detailed information are private to customers, or like, for instance, the credit card credentials, the credit card information that are being transmitted over the e-commerce websites, or any other private information, okay? So again, you need to account for that. Finally is the streaming data. Streaming data is like data that, a data stream is actually a transaction or a couple of transactions that occur once at a certain point of time. So sometimes we need to mine this data, like for instance, the transactions on ATM machines, okay? So if someone is making an ATM transaction, and at the same time you need to predict if this customer is a fraudulent customer or is entering a wrong credit card or not, or actually has stolen this credit card or not. So at the point that the transaction is being made, you need to evaluate this transaction, and based on your data mining tasks, you need to be able to predict if this customer is, for instance, is a thief or not, whatever, okay? Or like, for instance, the network detection that we have just mentioned of the intrusion network detection, you will be able to find out or predict if this is an intruder or not on the same spot, at the same time, okay? While the data is being streamed. Okay, no problem, Amani. But please make sure if you come late or you're not or as we agreed yesterday, if you're still working now, please make sure that you listen to the session again. Okay. So now we have finished this chapter 1. As I told you before, you have 2 textbooks for this course, one by Kumar and one by Camber, okay? For this chapter, and I told you before that we're trying to customize the slides. This has not been yet confirmed, but it will be confirmed, inshallah, by next week with the course coordinator and the other instructors of the course, okay? Right now, since we have finished this one, I'd like to go through the first chapter also of the second book, which is by Camber. Can you see the PowerPoint slide here? Of the second textbook. Can you see the second PowerPoint? Okay. Still chapter 1. Yeah, chapter 1 of this is another PowerPoint presentation. It's chapter 1 of Camber. This one. This is another presentation. Can you see this one, or is it? Okay, perfect. Okay. Right. We have already explained the major issues in this chapter, whether in the Camber book or Kumar book, but I like more the presentation or the chapter by Kumar, chapter 1, especially in this week, Chapter 1 by Coomer. Okay, you are also required to have a quick read about Coomer as well. Go through the chapter and the slide here. This is just the course structure and the slide, etc. Here in this book, they have also introduced why data mining. So you will find that it's almost in a way or another the same thing that we have explained, but maybe with more examples. What is data mining? What is a multi-dimensional view of data? Okay. What kinds of data can be mined? What kind of patterns can be mined? So these are always examples. So please make sure that you read them. Okay. What kind of technologies are used? What kinds of applications are targeted? Major issues in data mining. This is very similar to the ones that we have discussed in the last slide. And then a brief history about data mining and data mining society. Okay. This is data mining. What I would really like you to also focus on is this graph in slide 9, where it shows you the process of the knowledge discovery. Okay, again, this whole process is called knowledge discovery because we agreed before that data mining means mining the data in order to discover, or analyzing the data in order to discover new knowledge. So from data to knowledge, this is called the knowledge discovery process. We start with the data with data sources. Okay, here are different data sources. Then we need to clean this data to create a data warehouse. A data warehouse is a structure where we store our data in a certain format that allows us to mine it. Okay, from this data warehouse we select the relevant data that we need for mining. We'll not take the whole data. We'll just take only the data that we need. Then we mine the data. Once we mine it, we come up with new patterns. We evaluate these patterns and come up with our new knowledge. Of course, this process has a feedback or has a loop. So for instance, if you find that you need more knowledge, or if you find that you have some missing data, so you go back here and do and select more data. Okay. And then go back to mining as well and pattern. If you find that you have come up with new knowledge, so you can create a new database of new knowledge, then you can integrate it here with these sources as well and use it again for the data warehousing and data mining as well. Okay, is the image clear? Is this chart or drawing clear? Okay. Also, this one is very important, which says data mining in business intelligence. Okay, now if you're, why do we call it business intelligence? Because we agreed again that data mining gives us new knowledge. So having new knowledge makes our business actually more intelligent, or makes the companies more intelligent because they are able to make smarter. It starts, well, again, with, this is the pyramid of having a business intelligence process. We have start with the different data sources, can be paper, files, web documents, scientific experiments, database systems. Then we have the data pre-processing, integration, and then we come up with the data warehouse. Then we try to explore it by using, after the data exploration, this is just an ordinary task. We have statistics, summaries, querying, reporting, okay? Then we start with the data mining, where we discover new information. Discovering new information, we can, so we have now new information, new data, that can be plotted or that can be drawn into a way that is easily that can be easily understood by managers and users and end users. So we come up here with the data presentation. We visualize what we have found in the data mining using some visualization techniques, okay? And then based on this, we present it to the end user who can make decision or critical decisions, okay? So this part is related to the database administrator, where we're talking about databases, cleaning the data, integration, etc. This part where we have data mining, this is related to the data analyst, okay, who applies the different data mining tasks. This part where we present now the mined data, this data is now given to the business analyst, who presents this data in certain charts or drawings that can help the end user to make decisions. So now decision making. So as you see now, they're all working here to serve in the end who? The end user. And of course, the ones who are going to they make a decision, for instance, in a company, it will be the top management, okay? In the case of Amazon.com, it will be who's making the final decision. It's you, actually, the end user who's using the website, whether to buy or not to buy this book, etc. So what we have done is here throughout this process, we have increased. All right? Is this clear, everyone? Is this clear, everyone? Okay. As you see here, again discussing here the classification, the clustering, the outlier analysis, what we call the direction analysis, sequential pattern again, okay? This is also important to know. I have already told you before that data mining integrates different disciplines. In the other chapter that we have just mentioned, statistics, machine learning techniques, and databases. Here, they're also providing more disciplines, which is true. The other one is more general. We have data mining, it integrates machine learning, statistics, okay, database, and also pattern recognition techniques, which is related to, in a way or another, to machine learning and artificial intelligence, okay, applications, visualization, where we visualize or draw charts of our discovered data, algorithms, and high-performance computing. Okay, why high-performance computing? Because again, we are dealing with huge amounts of data that need a high-performance processing. And this is again the same thing. Why do we have this multiple disciplines? Because of the amount of data, the dimensionality, and the complexity of data. So it's actually the same thing, but explained just in a different way. These are applications of data mining, also extra examples, so please have a look at it. And major issues again, and that's it. So we are done here. Now we are done. Okay? Any questions? Any questions regarding chapter 1? Okay. Please don't forget again to read the chapter from those books. It will enrich your mind. It's clear. So once you read, you will be able to. It will be even. Of course, you're expected to read it before we explain. But for those who haven't read it, please read it. Okay. And for those who have read it, please go again through the slides to make sure that everything is set in your mind. Okay. This will help you, believe me, a lot when it comes to preparing for your exam. Studying will be just a piece of cake for you. Okay. Have a good weekend, inshallah, and see you next week. Thank you very much.